sine law, but sometimes we can't always use the sine law. So just to recap, we can use the sine law when we know two sides and an opposite angle, or two angles and any side. So we need an angle and its opposite side. But there are cases, let's see here, where that doesn't help. So look at this triangle here. We have two sides, we have an angle, but we don't have an angle opposite one of those sides. So if we try to use the sine law, we set it up, well, 3.1 is opposite R, 3.2 is opposite S, and 66 is opposite Q. There's no way that we can use this to solve for anything. We have two unknowns any way we look at it. Can't do it. Okay, here's another case. Here we have, whoops, two sides, three sides, no angles. We don't know a single angle. So we try setting that up, and we can't solve for it. So this is when we're going to use a new law, and it's called the cosine law. And we use this is based on Pythagoras' theorem. So we're going to see if we can prove it. So here's a little sneak preview of what it looks like, but we're going to see if we can prove it. Okay. So here we have a triangle in general. And the one thing that we do need for this is instead of this whole length being called A, well, it is still called A, we're going to look at this point X and this point Y as those two sides there, so we can use Pythagoras. Just a reminder, Pythagoras is A squared plus B squared equals C squared. And it doesn't matter, A and B can be any leg, so any of the short ones, but C has to be that hypotenuse. Okay, so let's set up, just like we did for the sine law, let's set up an equation, expressions for H. Okay, so is H, can we substitute for A, B, or C and Y? We can only substitute H for A or B, and that's because it is not the hypotenuse, it is a leg. So let's look at this triangle over here. In this case, I know that x squared plus h squared is equal to c squared. Solving for h squared, I get h squared is equal to c squared minus x squared. Okay, in my other triangle, in this triangle right here, I have that y squared plus h squared is equal to b squared. Solving for h, I get h squared is equal to b squared minus y squared. And again, that's important because these are my hypotenuses. Those have to be on the edge. Those have to be the two other legs squared, add up to equal those. Now, check this out. H squared equals something. H squared equals something. Well, guess what? Those somethings equal each other. So c squared minus x squared is equal to b squared minus y squared. Okay. Now what I'm going to do is I'm going to solve for c squared. I'm going to say, well, c squared then has to equal b squared plus x squared plus y squared. Okay. Now when I'm given a triangle, because again, what I would be given is just a triangle, the triangle A, B, and C. I'm going to be given side lengths. I'm not going to be given these x's and y's. So what I want to do is I want to eventually try and get rid of x and y. So the first thing I'm going to do is I'm going to say, well, I know that I could write x in terms of y. Okay? And the reason I can do that is I know that a minus y, this whole thing's a, if I subtract y from it, I'm left with x. And now it's okay that I use a because a is a side of the triangle that I might be given. Okay, so again, I said that x is equal to a minus y. I have that whole length a, and I said, well, this is y, this is x. All of a, if I take away y, I'm left with x. Okay, so wherever I see x in my equation, I'm going to substitute in this relationship that I just discovered, I just highlighted. A minus y squared plus y squared. Okay. Now, here I'm squaring a binomial. Let's just expand that. So I FOIL, it's like saying a minus y times a minus y. So I get a squared first, outside, minus ay, minus ay. So I get minus 2ay. That was outside and inside. And then I get last. Minus y times minus y would be y squared. So that's just expanding this whole thing. Then I still have this plus y squared at the back. Okay, let's see. Well, I have plus y squared. Wait a sec. Oh, I made a mistake up here. Just a copying error. That's frustrating. So all of a sudden, I just said, I changed this to a plus sign when it should have been a minus. Okay, so that would have been minus y squared. Minus y squared and minus y squared. Copying errors. Those are the worst. Okay. So I have plus y squared minus y squared. Those cancel out, as they should. Life is good. B squared plus a squared minus 2ay. Now remember again, I'm eventually trying to get rid of these a's and y's because I won't be given an a's and y's in a triangle question. I will just be given sides of the triangle. I won't be given parts of the sides of the triangle. Okay, so let's look at y. Let's look very closely back at our formula here, at our, diagram here at y. Whew. Okay. So what I would be given potentially in a question would be B, C, all of A, angle C. So let's get y in terms of things that I would be given. Well, I would be given maybe B or C. So what's a trig ratio that relates an angle, something adjacent, and its hypotenuse? Well, that would be cosine. In other words, I could say that the cos of C is equal to adjacent, which would be y, over hypotenuse, or B. So if I want to get rid of y, I could substitute something for it. So too much junk here. Let's solve for y here. Times both sides by b. So I get b cos c is equal to y. So that's another relationship I found. So wherever I see y, I'm going to put what I just wrote, which was up here, cos c, b cos c. Too fast. Okay. So c squared equals b squared plus a squared minus 2a. And instead of y, I'm going to write c cos b, b cos c, b cos c. And this is the sine law. Cosine law. Cosine law. Sheesh. Okay, so let's read what that is here. The cosine law can be used to determine an unknown side length or angle measure in an acute triangle. And its relationship is if we have a side squared is equal to the sum of the other two side squares, b squared plus c squared, minus 2bc cos a. 2 times bc cos of a. Did I have that right back here? Did I have a minus sign? Oh, good, I did. I had a moment of I forgot. Okay. So in order to use cosine, if we know any two sides in a contained angle, so we don't know the opposites. If we did know the opposites, we could use what? Sine law. Okay, or if we know all three sides, then we're going to use this. Okay, the contained angle is the angle between the two known sides. When using the cosine law to determine an angle, you can substitute the known values first, then solve, or rearrange and then sub in. Okay, so let's look at this problem. This is on page 132. So what we're going to do is we're going to see if we can make this fit our model. Determine the length of CB to the nearest meter. Okay, so what information do we have? We have A. Oops. We have A. We have side length C. We have side length B, because remember, those are opposite. So we have to see how we can make this fit our model. And that cosine law, again, was a squared, b squared, or c squared can equal either one of those things. Well, what are we trying to find out here? Determine the length of CB. Well, CB is called A. A is what we're trying to find out. So we want to use, CB is the same as A because it's opposite. We want to use this form. A squared is equal to B squared plus C squared minus 2BC cos A. B squared plus C squared minus 2BC cos A. And now what we're doing is we're just summing in the values we know. A squared is what we're trying to find out. B squared. Well, what is side length B? It's opposite angle B. It's 32 equals 32 squared plus C. Side length C is opposite angle C. So that's 40 plus 40 squared minus 2. Side B again was 32. Side C again was 40. And the cos of angle A, so the cos of 58. Okay, I want to do as much of this as we can in our calculator. So the more you can do in the calculator, the better your answer will be, and the less headaches, less chance of errors. Okay, so in your calculator, I want you to type 32 squared plus 40 squared minus, and now we're going to do some brackets, minus bracket 2 times, oh, I messed up already, 32 squared plus 40 squared minus 2 times 32 times 40 times 58 cos equals, I have 1,267.4. Well, that seems kind of big. Oh, right, it's not just A, it's A squared. So now we're going to square root both sides. We're going to get A is equal to, so I'm going to find my square root button, is equal to 35.6. Does that make sense? The triangle with side lengths 32, 40, and 35? Yeah, that seems a little reasonable. Okay, so again, what you're going to do is you're going to write out your known information. Sometimes you have to relabel a triangle ABC. That's what I would always start with, is redraw it out and label it ABC. Then turn to page 136 in your textbook, look at these different forms of the cosine law and see how it fits. Okay, so a couple questions to try on your sheet. Where's my recorder? There we go.